Hello students, I am Dr. Sangeeta Sharma, your science teacher. Today we will be continuing with chapter 13 of your science book, that is magnetic effects of electric current. And in today's video, that is part 10, exercises 2, we will be solving the remaining problems given at the end of the chapter. So students, we have already solved certain problems, and in today's video we are going to solve the rest of the problems given at the end of the chapter. So students, let's begin with the problems. So students, question number 12. Question number 1 to 11 we have done in our previous video. So question number 12. Name some devices in which electric motors are used. Now here we need to write the names of some devices in which electric motors are used. So we will write the answer like this. Electric motors are used in the appliances like electric fans, washing machine, mixers, grinders, blenders, computers, MP3 players, etc. Now let's see the next question. Question number 13. A coil of insulated copper wire is connected to a galvanometer. What will happen if a bar magnet is first pushed into the coil? अब बच्चों यहाँ पर क्या है, यहाँ पर एक कॉइल है इंसुलेटेड कॉपर वायर की जिसको कि कनेक्ट किया हुआ है एक गैल्वेनोमीटर के साथ में, और फिर एक बार मैग्नेट को उस कॉइल के अंदर पुश किया जाता है तो क्या होगा? तो हमें पता है स्टूडेंट्स कि जब बार मैग्नेट को उस कॉइल के अंदर जिसके साथ में गैल्वेनोमीटर भी अटैच्ड है, तो जब इस बार मैग्नेट को पुश किया जाएगा तो मैग्नेटिक लाइंस जो उसके साथ में लिंक्ड हैं, मैग्नेटिक फ्लक्स जो उसके साथ में लिंक्ड है वो चेंज होगा। तो जब मैग्नेटिक फ्लक्स चेंज होगा तो करंट इंड्यूस होगा। सो स्टूडेंट्स, हम आंसर को इस तरीके से लिखेंगे। आंसर: एज अ बार मैग्नेट इज पुश्ड into the coil, a momentary deflection is observed in the galvanometer, indicating the production of a momentary induced current in the coil. Now let's see the next part of question number 13. A coil of insulated copper wire is connected to a galvanometer. What will happen if a bar magnet is withdrawn from inside the coil? अब क्या कर रहे हैं बच्चों, जिस बार मैग्नेट को हमने उस कॉइल के अंदर पुश किया था, अब हम क्या कर रहे हैं, उस बार मैग्नेट को उस कॉइल के अंदर से वापस से बाहर निकाल रहे हैं। तो अब क्या होगा, गैल्वेनोमीटर ने पहले तो डिफ्लेक्शन कब शो किया, जब हमने उसको अंदर पुश किया, उसके बाद में वो मोमेंटरी जो डिफ्लेक्शन था वो फिर खत्म हो जाएगा। जैसे ही उसका मोशन रुक जाएगा तो चेंज इन मैग्नेटिक फ्लक्स रुक जाएगा, इसलिए इंड्यूस्ड करंट डेवलप नहीं होगी। अब अगर हम वापस से उस बार मैग्नेट को उस कॉइल के अंदर से वापस से खींच रहे हैं तो अब अगेन क्या होगा स्टूडेंट्स, वापस से मैग्नेटिक फ्लक्स जो कॉइल के साथ में लिंक्ड है वो चेंज होगा। पहले वो इंक्रीज हो रहा था, अब वो डिक्रीज होगा। तो यानी कि वापस से गैल्वेनोमीटर के अंदर डिफ्लेक्शन शो होगा बट अपोजिट डायरेक्शन के अंदर, यानी कि इंड्यूस्ड करंट तो डेवलप होगी पर अपोजिट डायरेक्शन के अंदर डेवलप होगी। So, हम आंसर कैसे लिखेंगे स्टूडेंट्स? आंसर: when the bar magnet is withdrawn from the coil, the deflection of galvanometer is in opposite direction, showing the production of an opposite induced current. Now let's see the third part of question number 13. A coil of insulated copper wire is connected to a galvanometer. What will happen if a bar magnet is held stationary inside the coil? अब अगर कॉइल के अंदर जो बार मैग्नेट है उसको रख दिया जाए, यानी कि उसके अंदर कोई मोशन नहीं हो, उसको स्टेशनरी रख दिया जाए, तो क्या होगा? तो क्या होगा, मैग्नेटिक फ्लक्स तो चेंज नहीं होगा। तो जब मैग्नेटिक फ्लक्स चेंज नहीं होगा तो कोई भी इंड्यूस्ड करंट नहीं होगा, यानी कि गैल्वेनोमीटर में कोई भी डिफ्लेक्शन नहीं होगा। क्योंकि बच्चों हमें पता है कि जब तक मैग्नेटिक फ्लक्स में चेंज नहीं हो, मैग्नेटिक लाइंस में चेंज नहीं हो, मैग्नेटिक फील्ड में चेंज नहीं हो, तब तक इंड्यूस्ड करंट डेवलप नहीं होता। यही प्रिंसिपल है इलेक्ट्रोमैग्नेटिक इंडक्शन का। सो स्टूडेंट्स, वी विल राइट द आंसर लाइक दिस. When the bar magnet is held stationary inside the coil, there is no deflection in galvanometer indicating that no current is produced in the coil. Now, let us see the next question, which is question number 14. Two circular coils A and B are placed close to each other. If the current in the coil A is changed, will some current be induced in the coil B? Give reason. अब बच्चों यहाँ पर दो सर्कुलर कॉइल्स हैं A और B जो कि एक दूसरे के पास में रखी हुई हैं। अगर A कॉइल के अंदर करंट को चेंज किया जाए तो क्या कॉइल B के अंदर कोई करंट इंड्यूस होगा? गिव रीजंस, हमें उसके अंदर सपोर्ट के अंदर जो है उसका रीजन भी देना है। तो हमें पता है स्टूडेंट्स कि यस, एक इंड्यूस्ड करंट होगा और क्यों होगा? इलेक्ट्रोमैग्नेटिक इंडक्शन के अंदर होगा, के कारण होगा। सो हम आंसर को इस तरीके से लिखेंगे स्टूडेंट्स, यस, some current will be induced in the coil B. Due to change in current in coil A, the magnetic field lines linked with coil A and hence with coil B gets changed. This sets up induced current in coil B. Let's see the next question, which is question number 15. State the rule to determine the direction of a first magnetic field produced around a straight conductor carrying current. Now students, here what they have asked, state the rule to determine the direction of a magnetic field produced around a straight conductor carrying current. तो यहाँ पर स्टूडेंट्स हमें रूल का नाम लिखना है और फिर उसका स्टेटमेंट भी लिखना है। तो हमें पता है कि एक स्ट्रेट वायर जिसके अंदर से करंट फ्लो हो रहा है उसके चारों तरफ मैग्नेटिक फील्ड की डायरेक्शन अगर हमें निकालनी हो तो हम राइट हैंड थंब रूल यूज करते हैं। सो स्टूडेंट्स, राइट हैंड थंब रूल स्टेट्स दैट if the current carrying conductor is held in the right hand such that the thumb points in the direction of the current, then the direction of the curl of the fingers will give the direction of the magnetic field. So, we will support our answer with the help of a diagram. So, here what we see students, that if the conductor is so held that the direction of the thumb shows the direction of the current, then the curl of the fingers will show the direction of magnetic field produced. So, here the direction of magnetic field is anti-clockwise. So, if I say this is a conductor and the nib points towards the direction of current, and if I hold this conductor in my right hand, we suppose that we hold this conductor in the right hand and the thumb points in the direction of current. So, the curl of the fingers gives the direction of magnetic field. So, here what we see is that the direction of magnetic field is anti-clockwise. Now, if the direction of current in the conductor is downwards, then the curl of the fingers which will give the direction of magnetic field is clockwise. This we have shown here also students, that if the direction of current is downwards, then the curl of fingers is giving the direction of magnetic field which is clockwise. So, this is the direction of magnetic field. Now, let us see the next part. Question number 15, part 2. State the rule to determine the direction of a force experienced by a current carrying straight conductor placed in a magnetic field which is perpendicular to it. We know students that the rule is Fleming's left hand rule. So, Fleming's left hand rule states that if we stretch the forefinger, the central finger and the thumb of the left hand mutually perpendicular to each other, if the forefinger points in the direction of the magnetic field, the middle finger in the direction of current, then the thumb points in the direction of force in the conductor. So, here students, we have shown a left hand, and if the two fingers and the thumb is stretched perpendicular to each other, mutually perpendicular to each other, then what we see is that if the forefinger is giving the direction of magnetic field, here you can see students, the forefinger is giving the direction of magnetic field and the central finger is giving the direction of current, then the thumb will give the direction of force. So, this is the Fleming's left hand rule. Now, let us see the next part. Question number 15, part 3. State the rule to determine the direction of a current induced in a coil due to its rotation in a magnetic field. Now, as we know students that the answer is Fleming's right hand rule, and we will give the statement. So, Fleming's right hand rule states that if we stretch the thumb, forefinger and the central finger of the right hand mutually perpendicular to each other, if the forefinger points in the direction of magnetic field, thumb in the direction of motion of the conductor, then the middle finger points in the direction of current induced in the conductor. So, Fleming's right hand rule is shown here. Here we have shown a right hand, and what we see is that the forefinger is pointing towards the magnetic field and the thumb is pointing towards the direction of force, that is motion. Then the middle finger will give us the direction of induced current. So, students, let us see the next question. Question number 16. Explain the underlying principle and working of an electric generator by drawing a labeled diagram. What is the function of brushes? Now, students, here in this question they have asked that state and explain the underlying principle and working of an electric generator. Now, students, here we know that we have two types of electric generator. So, first we will give the principle of electric generator, then we will give the working of both AC generator and DC generator. So, students, electric generator is a machine used for producing electric current or electricity. The electric generator converts mechanical energy into electrical energy. Now, students, the principle of electric generator. The electric generator works on the principle that when a straight conductor is moved in a magnetic field, then current is induced in the conductor. That is, electric generator is based on the principle of electromagnetic induction. Now, students, we have two types of electric generator. So, types of electric generator, AC generator and DC generator. So, AC generator, what is AC generator? An AC generator converts mechanical energy into electric energy in the form of alternating current. So, first we will understand and we will see that how a AC generator works. So, this is a labeled diagram of AC generator. Here we have the north pole and south pole of a strong horseshoe magnet. ABCD is the armature coil. Here we have two slip rings R1 and R2. This is R1 ring and this is R2 ring, which are mounted over the axle. Then we have two brushes B1 and B2. Brushes B1 and B2. B1 is pressing against R1 ring and B2 is pressing against R2 ring. Then we have an external circuit where a galvanometer is also attached. So, we have given the label diagram of a AC generator. Then we will do the working. As the armature is rotated about an axis shown dotted, the magnetic flux linked with the armature changes. Therefore, an induced current is produced in the armature. And here we will see, students, that here for simplicity we have shown only a single turn in the armature coil. As such, we have more turns in the armature coil. So, here students, what we see is that we have a armature coil ABCD which is rotating between the two poles north and south pole, and this armature coil is made to rotate somehow in the anti-clockwise direction. And now we will calculate the direction of induced current using the Fleming's right hand rule. So, we will study the working in two parts. In the first half rotation, what we will do is we will study the working in the two halves. So, for the first half rotation, let us suppose that the armature ABCD is rotating anti-clockwise, so that the arm AB moves inwards and CD moves outwards. Applying Fleming's right hand rule, we find that the induced current in the armature and in the circuit is anti-clockwise as shown in figure, due to which G shows deflection towards the right. Now here students, we will see that how the direction of induced current is calculated. So if I stretch the fingers of my right hand, then as we know that if the direction of motion is indicated by the thumb and the direction of magnetic field is given by the forefinger, then the middle finger gives us the direction of induced current. So in arm AB, north to south, this is the direction of magnetic field and the arm AB is moving inwards. So what we see is students, that the arm AB is moving inwards, so the thumb is pointing inwards. The direction of magnetic field is like this. So what we see is that the direction of middle finger is pointing downwards. That is, the direction of induced current is downwards. So here the direction of induced current is downwards. Now here in arm CD, which is moving outwards, the direction of magnetic field is like this only. So now the arm CD is moving outwards, so I have kept the thumb pointing outwards and the middle finger gives the direction of magnetic field. Then what we see is that the direction of induced current is upwards. So what we conclude here is that the direction of induced current in arm CD is upwards. So what we see, that the direction of current in the armature coil is anti-clockwise, and since this AB arm is attached with ring R1 and this is pressed against the brush B1. So what we see is that the current from this arm, that is in the direction BA it is flowing. So the current from the arm AB, it reaches ring R1 and through brush B1 it enters the external circuit, and the direction of current in the external circuit is like this. And what we see is that hence the direction of current in the galvanometer is so indicated that the galvanometer shows deflection on the right hand side, and hence the current now enters the slip ring R2 through the brush B2 and hence it is connected to the arm CD. So what happens is that the direction of current is again in the anti-clockwise direction. Now after the half rotation, that is when the armature is rotated through 180 degrees. Now what happens is that this arm AB will now flip and come towards the right hand side, and the arm CD will flip and come towards the left hand side. Students, here the armature coil was like this and now it has rotated through 180 degrees and now it will be like this. So let us understand for the next half rotation. So students, for the next half rotation, after the armature has turned through 180 degree, it occupies the position shown in figure, with the armature rotating in the same direction, that is anti-clockwise. CD moves inwards and AB moves outwards. Now here students, the arm CD is now on this side, arm AB is now on this side. Now since CD is now moving inwards because the armature is rotating in the anti-clockwise direction. So now the arm CD is moving inwards, so the direction of current here by Fleming's right hand rule will be downwards, and since the arm AB is moving outwards, so by Fleming's right hand rule the direction of current is going to be upward. So what we see is that now since CD is connected to ring R2 which is pressed by brush B2, that is B2 is pressed against R2. So now this current will now flow in the external circuit like this, that is at the load resistance we will have current in this direction, which is reverse of the direction in the previous case. So what we see is that the galvanometer will show deflection on the left hand side, and now the current will enter the slip ring R1 through the brush B1, and since this R1 is connected to AB arm, the current will flow like this. So what we see is that in the external circuit the direction of current has reversed. So students, Thus, again applying Fleming's right hand rule, we find the induced current in the external circuit R and G flows in the opposite direction, due to which the direction of deflection in the galvanometer is towards left. Thus, we see that the direction of induced current changes in external circuit after every half revolution of the armature. That is, after the armature has turned through an angle of 180 degree from its initial position. Hence, the induced current is alternating in nature. So, like this students, the mechanical energy is converted into electrical energy, which is of alternating nature. Now students, we will learn about the DC generator. A DC generator converts mechanical energy into electric energy in the form of direct current DC. The principal construction and working of a DC generator is the same as that of an AC generator, except that in place of slip rings as sliding contacts, we have a split ring or a commutator. So, here students, we are having a DC generator, and in DC generator, as the name indicates, mechanical energy is converted into electrical energy, which is of direct nature. Now, here students, everything is the same except that in the construction, instead of slip rings, we have split rings. That is, we have two halves of a single ring, and due to this difference, what happens is, in the external circuit we get current always in the same direction. So, here you can see students that here we are having two split rings which are two halves of a same ring. So, P and Q are two split rings. These are the two split rings, and we have two brushes X and Y. So, here we have the brushes X and Y. We have the poles north and south of a horseshoe magnet, which is very strong magnet, and here we have a galvanometer attached in the external circuit, and this split ring is mounted over a axle, and ABCD is the armature coil, and with these arrows we have shown the direction of magnetic field. So, now let us understand the working of a DC generator. In a split ring, P and Q are the two halves of the same ring. The ends of the armature coil are connected to these rings, and these rings rotate with the armature. As is clear from figure A and B, by using the split ring, the direction of induced current does not change in the external circuit throughout the complete rotation of the armature. Here what we see is students, in the first half rotation, what we see is that the armature coil is rotating in anti-clockwise direction. So, the AD arm is moving inwards and BC arm is moving आउटवर्ड्स. तो बच्चों यहाँ पर क्या है, अभी हमने जैसे देखा कि फ्लेमिंग राइट हैंड रूल को जब हम यूज करेंगे तो एडी आर्म जो कि इनवर्ड्स मूव कर रहा है उसमें इंड्यूस्ड करंट की डायरेक्शन नीचे की ओर आएगी, और बीसी आर्म जो कि आउटवर्ड मूव कर रहा है फ्लेमिंग राइट हैंड रूल से इंड्यूस्ड करंट की डायरेक्शन जो है वो अपवर्ड आएगी. अब क्या होता है कि एडी आर्म जो है वो कनेक्टेड है पी रिंग के साथ, और पी रिंग के अक्रॉस जो है B1 ब्रश जो है वो प्रेस किया हुआ है. तो यानी कि ये जो इंड्यूस्ड करंट है ये पी स्प्लिट रिंग से B1 ब्रश के थ्रू एक्सटर्नल लोड के अंदर जाएगा. यानी एक्सटर्नल लोड में हमें करंट की डायरेक्शन जो है वो इस तरीके से मिलेगी. यानी गैल्वेनोमीटर जो है वो राइट हैंड साइड में डिफ्लेक्शन शो करेगा. फिर ये करंट B2 ब्रश से Q स्प्लिट रिंग के अंदर चला जाएगा और फिर आर्म CB के अंदर इस डायरेक्शन के अंदर मूव करेगा. यानी कि आर्मेचर के अंदर जो इंड्यूस्ड करंट की डायरेक्शन है वो एंटी क्लॉकवाइज होगी और एक्सटर्नल सर्किट के अंदर जो करंट की डायरेक्शन है वो इस तरीके से होगी. अब स्टूडेंट्स, हाफ रोटेशन होने के बाद में यानी कि 180 डिग्री से जब आर्मेचर कॉइल रोटेट कर चुकी है तो अब पोजीशन क्या होगी, ये जो BC आर्म है अब ये अब इस तरफ आ जाएगा और AD आर्म जो है वो इस तरफ आ जाएगा. तो अब आर्मेचर कॉइल तो एंटी क्लॉकवाइज ही रोटेट कर रही है इस एक्सिस के अबाउट, तो क्या होगा, BC आर्म जो है वो अब इनवर्ड्स मूव करेगा और एडी आर्म जो है वो आउटवर्ड मूव करेगा। यानी कि अगर हम फ्लेमिंग्स राइट हैंड रूल दोबारा से लगाएं तो यानी कि इसमें डायरेक्शन जो है वो नीचे की तरफ होगी और इसमें डायरेक्शन जो है वो ऊपर की तरफ होगी। तो ये जो बीसी आर्म है जो कि इस रिंग P के साथ में अटैच्ड है, उसमें क्या होगा कि वो B1 ब्रश के थ्रू एक्सटर्नल लोड के अंदर करंट की डायरेक्शन वापस से वही होगी जो फर्स्ट हाफ रोटेशन के केस में थी। तो गैल्वेनोमीटर जो डिफ्लेक्शन शो करेगा वो वापस से राइट में ही शो करेगा, यानी कि करंट की डायरेक्शन आर्मेचर में तो एंटी क्लॉकवाइज होगी और बाहर का जो एक्सटर्नल सर्किट है उसमें भी करंट की डायरेक्शन में कोई चेंज नहीं होगा। यानी कि मैकेनिकल एनर्जी किस में कन्वर्ट हो गई? मैकेनिकल एनर्जी डायरेक्ट करंट के अंदर कन्वर्ट हो गई। नाउ स्टूडेंट्स, वी हैव, in other words, the current in the external circuit always flows in the same direction. Hence, the induced current is unidirectional, that is direct current. Now, what is the function of brushes? This was asked in the question, so we will write the function of brushes. Brushes are made out of carbon or gunmetal. Their one end presses tightly against the slip rings. The current induced in the coil flows out of the slip rings through brushes. Right, students? Now, let us see question number 17. When does an electric short circuit occur? Now, students, we will write the answer like this. In a domestic circuit, short circuit occurs when live and neutral wire come in direct contact with each other. The resistance of the circuit becomes very low and excessive current starts to flow through it. Consequently, a large heating effect is created which may lead to fire. Now, students, let us move to the next question. Question number 18. What is the function of an earth wire? Why is it necessary to earth metallic appliances? So, we will write the answer like this, students. Earth wire is a safety measure that provides a low resistance conducting path to the current. Sometimes due to excess heat or wear and tear, the live wire comes in direct contact with the metallic cover of the appliances, which can give an electric shock on touching them. Hence, students, to prevent from the shock, the metallic part is connected to the earth through a plug, due to which the current flows to the earth at the instant there is a short circuit. It is necessary to earth metallic appliances because it ensures that if there is any current leakage in the metallic cover, the potential of the appliance becomes equal to that of the earth. The potential of the earth is 0. As a result, the person handling the appliance will not get an electric shock. So, students, इसलिए earthing करना बहुत ज़रूरी है. So, students, today we have done the remaining exercises given at the end of the chapter. Hence, we have completed the chapter. So, students, for the new chapter, stay safe, stay healthy. Bye.